So for this, we need to... Would 20 be the numerical?
Yeah.
And the probability is 2 over 5.
Yeah, I'm just going to write 0.4 because we'll get all the others as decimals as well.
Yeah. And then would 11 be the lower?
So I just need to think about this. So the null hypothesis is kind of the assumption, the default assumption. Let's see. That would be the probability is 0.4.
Yeah.
And that's its old chance of success. They then changed it, and so we're assuming its new chance of success. Would it be more or less?
It's less.
Just want to say, so what's 2/5 of 20?
8.
Or no, I tell you what. So 2/5 is 0.4. What is 11 over 20 as a decimal?
Not 0.55.
So that would be, it went up.
Yeah.
Where P represents, so it helps to do that bit as well. Probability of the drug being successful. Okay, so yeah, lower is 11, upper is 20. Try that.
I got 0.12752.
So probability x is greater than or equal to 11. 0.1, what was it?
12752.
5.2. So that's 12.8%.
Yep.
And so use that to test this claim.
Okay. So we want a number that's below 5% or 0.05.
Yeah, and this one isn't. This is less than 5%. Therefore,
the claim is false.
Yes, and so we have insufficient evidence at the 5% significance level to reject the null hypothesis, and so we accept the null hypothesis. It would have to be something that happens very rare. This could just be by random chance. So I'm taking your word for it on these numbers.
Yeah.
Hopefully, so 11, 20, 12.75% is greater than 5%, so there's not enough evidence. Yeah, so this, just by chance, this happens 11 times out of 20.
Yeah.
So, yeah, you did that pretty handily, Adam, I'm not going to lie. I just want to use the other method.
Okay.
So it's exactly the same as what we were doing before, finding the critical value. So just so we don't have any like other methods. So stats, distribution, binomial cumulative, number of trials is 20. That's 0.4. Upper is 20. And so our old method would be we would try to find the critical value.
Yeah.
Oh, looks like it's 15. Let me try 14. 14 is, wait, 0, 0, 0. Hang on. 13, so that's 2%. And then that's just over. So the critical value is 13. And so he would need 13 out of 20 for it to be, at the 5% significance level. Yeah. So that would be using the same method we did before, finding the critical value and then comparing it to his value. Or you can do it your way. I'm fine either way. Right. Let me see this one. Right. Let's try this.
Okay. So would it be x is binomially distributed?
Yeah.
And then is it x?
Well, we have the x there. Am I crazy? I think you might have to go to part B for that.
Then?
I think you might have to go to part B to get
Oh,
the.
okay. So it's 40 then. With the,
Well, okay. Let's just leave it as n for now. Ah, yeah, in a sample of n people. Yeah.
and then the probability,
Yeah. What's that?
is that 90% or
Yeah.
0.09?
Hey, what is 90%?
0.9.
Yeah. And I prefer to use decimal because it's less confusing with 5% level significance, that they're not the same, they don't have anything to do with each other. Okay, that's good. B.
Okay.
And so use, any way you want. It doesn't have to be my way.
Okay, so new metrology 40.
Yeah.
And then P is 0.9.
Mm-hmm.
Would the lower be 33 and the upper be 40?
40, 0.9. Let's see. So H null. What would be H null?
Would it be... Wait, what do you mean by H null? Is it like...
So for our previous one, our null hypothesis, we assumed that the probability of success was 0.4.
So probability is 0.9.
So we're assuming probability 0.9. Okay, the alternative hypothesis, they're saying that his claim is overstated. So we're checking if his 90% claim is overstated. And so if that's true, then what's the alternative hypothesis?
P is greater than 0.9.
If he's overstating...
Oh, so it's lesser, yeah.
Yeah. So part of it is understanding the wording.
Yeah.
Okay.
And then would you do the lower and upper and then you neutral on the probability?
Okay, but what is lower, what is upper?
So would upper be 40 but you guessed the lower?
No, you can use your same method as before. You don't have to do critical
Okay.
values and stuff. Random. So I tend to think of the two extremes. So what would be the outcome if it was 0 people instead of 33? What would be the outcome if it was all 40 out of
1.
40? Well, hang on. So a random sample of 40 people. He fooled 33 out of 40. If he fooled all 40 of them, would his thing be overstated?
Yeah.
No. They're saying he's overstating it. So you would accept H1 if you got fewer people.
Okay.
Yes. And so what would you check for this?
You'd check for anything below 0.9.
You would check like lower would be 0.
And you'd change the upper.
Yeah, what would be upper?
Okay. 33.
Yeah, that's it. So it's the probability that x is less than or equal to 33.
I got 0.09952.
9. I think it's 9.92%.
Yeah.
Okay. And so we have to test his claim.
Oh, it's not. It's 9.95%.
95?
So-
Okay. And so, what about his claim?
So does his claim state that it's insignificant?
Well, 0.95% is greater than 5%. Therefore,
It's significant.
and so is he overstating his claims? Is it H null, H1?
It's H1.
No. It would have to be something that happens very rarely. So this happens about 10% of the time by random chance.
Okay.
And so it would have to happen only like 5% or less. So it'd have to be something that's quite rare.
Yeah.
This isn't rare enough to be... This could have just been by random chance. And so there's insufficient evidence at the 5% level of significance to reject the null hypothesis. Therefore, we accept the null hypothesis.
Yeah.
That's how these work. Yeah. Accept H null. Okay, let me see this. H null is that. H1. Okay. Let's see. Okay, let's try it.
Okay. So would her null hypothesis be equals 0.6?
What equals 0.6?
Would it be x is binomially distributed and then it would be 40 and then 0.6?
So x is binomially distributed. Well, 40 is the number of
Oh no, it
trials.
would be 30, which is the Maros.
Yeah. Okay. H null, H1.
Okay. And then would H null be... No, H1 be...
So what is H null?
Wait, is it just what it says to the right?
No. What is he claiming? That it'll
She's claiming that...
increase the proportion of marrows that are longer than 40
Yeah.
centimeters. And we're told that 60% of marrows are longer than 40.
Yeah.
So the alternative hypothesis would be the probability of getting a marrow that's longer than 40 centimeters would increase. So that would be, probability would be greater than 60%.
Okay.
Null hypothesis?
Probability that's equal to 60%.
Yeah. If you're flipping a coin, H null would be the probability lands in heads is a half.
Yeah.
And if you're testing that it's biased towards heads, you'd say, probability is greater than a half. Or if it's biased the other way, less than a half.
Yeah.
Okay, that's A. Part B.
Okay. So for this, would you have nu neutral as 30 and the probability is 0.6?
Yeah.
And then would you have the upper as 40 and the lower as 0?
Well, two things wrong, but that would give you one. That would give you an answer of 1. It's definitely between 0 and the maximum.
Okay.
Let's see. So either the lower is 0 or the upper is 30. And so we want to see if the number of marrows that are longer than 40 centimeters has increased.
Yeah.
And so what end are we looking at?
So we're looking at the lower end.
No. So this diagram here, you want like the proportion of marrows that if it's greater than, then we're looking at the higher end.
Yeah.
If the probability is increased, we'll be looking at the higher end.
Okay.
Because more marrows will be longer. Yeah. So the upper will be the maximum 30, and then you would just try different things for the lower.
Okay. It has to be below 5%. 0.05.
Yeah, correct, yeah.
Okay. I got 23 is the number.
And so the critical region is x is greater than or equal to 23. So if 23, so 60%, let's try to make sense of this. What's 60% of 30?
60% of 30. Is it 30? Was it a half?
3/5 of 30? 60%?
3. $18.
So 3/5 of 30 is 18. And so what is our critical region of 23 about? If you flip a coin, and it might not land on heads exactly half the time.
Yeah.
It might not land on tails exactly half the time. Let me go back to this. But what you would expect is like most of the stuff would be in between there. You know, let's say you flip a coin 14 times. 7 times it lands on heads. Like most of the time that happens. But 6 and 8 can also happen. You know, 5 and 9 can also happen. What you want is if it was to land like 14 heads out of 14, that would be a very rare occurrence.
Yeah.
It's not impossible. That's the difficulty about this. It's not impossible, but it's just so rare that we'll just accept that the coin is biased. Might not be. Might just be like freak chance. And so here, the middle of our thing, like what we're assuming would be 18. And our critical value is 23, where, you know, just by random chance, you might just get some that are a bit bigger, a bit smaller, you know, in any random batch.
Yeah.
But if we get if we get 23 or more, then that's something that happens so rarely. That's like the 14 out of 14 or 13 out of 14 heads. It's so rare that we'll say, okay, this new fertilizer worked. Okay, and question C.
Okay. So would you say that the fertilizer does increase the proportion of the marrows?
Correct. 25 is inside the critical region.
Yep.
Critical region. What was that? Therefore, the fertilizer worked. And so which H0 or H1?
H1.
Yes. Yep. There is evidence at the 5% level of significance to reject the null hypothesis, and so we reject it and accept the alternative hypothesis. Yep. 25 is in the critical region, so we reject the null hypothesis. Yeah. So it's like 25, it lands on heads 25 times out of 30. You know, it's not just it's not just something that kind of happens sometimes, like a little, it's something so rare that we say, yeah. Let's see this one. Right? See, it's a bit confusing. It's a little bit confusing. All right. Let's try this one.
So would it be x is binomially distributed, and then it would be 50, and then 0.1.
Well done.
And then would you say the null hypothesis is 0.1 equal p equals 0.1.
Mm-hmm.
And then the alternative null hypothesis is p is greater than 0.1.
Just want to say, so she decided to change the type of clay to reduce the proportion of that fracture. So currently,
So we want less of the probability because you want it to fracture less.
yeah. So at the moment it's 10%. She's trying to make it fracture less. Yeah.
Yeah.
Okay.
Okay. And then for this now, would you put the upper as 50?
So what are you what are you trying to check? So it says here
we're trying to check a significance level below 5%.
So you can just, so this is less than, so it'd be lower end.
Okay.
And we're told.
So for the lower end, what would you have the upper as then?
Well, for all of these, either the lower is 0 or the upper is n. And we're looking at the lower end.
So it's 0.
Mm-hmm.
And the upper would be, would you guess the upper then?
You could if you wanted.
Okay. I got 1.
How did you get 1? Oh,
So
that's x is 1, like the critical thing.
Yeah, it's below. So I got the answer of 0.03378.
Okay, and so the critical region is x is less than or equal to 1, because like 0 or 1. She fired her kiln and only one was cracked, and so test the hypothesis.
So the hypothesis did reduce the amount of the pots fracturing.
Yeah, it's within the critical region. Therefore,
Therefore, there was a decrease in the likelihood of pots fracturing.
All right. You have to say which hypothesis you're going with.
Oh, is it the first one?
Which one is that?
Top one.
Well, what's it
The
called?
null hypothesis. E equals 0.1.
No. Hey. Let's see. So you got it right up until the very end. So it did work. Yeah, she was trying to reduce her thing. 10% of 50 pots is 5 pots. And so, all things being equal, you expect about 5. You got only 1. Was that random chance, or was it because it worked? Well, the chance of it happening by random chance is only 3%, which is less than the 5% significance level, and so it worked. If it worked to reduce, if that did reduce the probability below 10%, then H1.
Okay.
There we go. Yeah. Okay, let's not do stuff. All right, let's give it a go.
Okay. So for this, would you just do 0.05 times 15?
15 houses. Not 0.05 times 15?
Yeah.
What would you get?
0.75 or 3 over 4.
Seems very high. To get 1 out of 15 houses and only a 5% chance. Salesman. So the probability makes a sale is 0.05.
Yeah.
He visits 15 houses in 1 day. Calculate. He makes at least 1 sale. So you want the probability that X is greater than or equal to 1. Because it could be like 1, 2, 3, 4.
Okay.
It would be. Well, what's the probability he makes no sales?
0. Out of 15.
No. Well, the probability he makes a sale is 0.05.
Okay.
So what's the probability he makes no sales?
Is there anything below 0.05?
No. Maybe I just give up on this stuff and we move on. Let's see. So this is binomial. He's got 15 houses. Okay, house 1, probability he makes a sale.
0.05.
Yeah. What's probability he makes the sale at the first 2 houses? How do you get the overall probability?
Would you add them?
Multiply.
Multiply.
Yeah. And so the probability he makes, and what's the short way of writing that?
Should I write in what?
Or tell you what, 3 houses.
Oh, it's just 0.05 to the 15.
Yes.
If you want to do 15.
Yes. Let me see. So the probability that he gets 15 out of 15 is 0.05 to the 15. What's the probability he doesn't make a sale at all? 15.
0.05 to the power of 0.
No. What's the probability he doesn't make a sale at the first house? It is 0.95.
Oh, okay.
Yeah.
Okay, I get it now.
And so probability he doesn't make any sales at all 15?
At all 15, would it be... Well, he doesn't make any sales.
Yeah. No sales whatsoever. All 15 doesn't make a sale.
So would it just be 0.05 altogether as like a number?
Nah. Be 0.95 to the 15. And so the probability he does not do that is 1 minus. Don't worry about it. Let's just
I
leave.
thought 0.95 was for the first house. Oh, but you... Okay, so you... Okay, I get it. Because you powered it to the 15 because there's 15 houses.
Yeah, but this is... it's kind of a different thing. Let's see. Test 5%. Alright, let's try B.
Okay. So it'd be x is binomially distributed, and then 26, and then would it be 0.05?
Well done.
And then it would be the null hypothesis is p is equal to 0.05.
So null hypothesis. Yeah.
The alternative null hypothesis would be p is lesser than 0.05.
He's trying to improve the likelihood of making a sale.
Should be greater.
Yeah. And let's see. So this was 26 houses. Okay, try it on.
Okay. So for this, would you put the upper as 26?
Yeah.
And then you just guess the lower.
Yeah. And well, they told you the lower was 4.
Okay. Which is 0.03874.
Say it again.
0.03874.
Okay, what do you do with that?
And then you state the hypothesis.
Alright.
That it doesn't increase.
Compare it to the significance level.
The significance level is 0.05, that means that's lower than 5%.
So that is less than 5%.
Which therefore means there's a decrease in the likelihood of making a sale.
H null, H1.
Oh, it would be H null.
No. Let's see. I need to redo this lesson. Let's see. I need to change how I teach this thing. It's very difficult. So I just did some calculations with this thing. You flip a coin 30 times. Number of times you expect it to land on heads.
Half.
So how many times out of 30?
15.
Okay. 15 is there. We get the idea. You'd have like some very rare 30, some very rare 0. For this question, he has a 5% chance he goes to 26 houses. 5%. See, they're using 5%, but it's also the significance level. That's why it's a bit confusing.
Yeah.
Times 26 houses equals, hang on, equals 1.3 houses. Okay?
Yeah.
If I was to do this, 1.3. What he tried his new sales pitch, and he sold to 4 houses. Okay, so well done. He sold 4 houses, so maybe that's like there. And you have to see how rare of an event is that. Did his thing actually work, or is it just, like how rare an event is, 17 out of 30 landing on heads? It's probably not that rare,
Yeah.
How rare is 4 houses out of 26 with a probability of 5%? Is it like, it seems like it's very close to 1.3, but that a coin is 50%. This is only 5%, so it's going to affect it that way.
Yeah.
It turns out it happens just by random chance. So 17 heads out of 30 probably happens a lot. 4 out of 30 with a 5% chance happens only 3.87% of the time randomly.
Yeah.
It's a very rare occurrence, and it's more rare than the significance level. And so, his new sales pitch actually changed it. It wasn't just random chance.
Yeah.
If it's less than the significance level, we accept H1.
Yeah.
Right. Let's see. Okay. Let's try 9-8.
So the X is binomially distributed.
Yeah.
And would it be 20 and then 4/10?
Yeah. Let's do 0.4.
And then would you say the null hypothesis is P is equal to 0.4?
Yeah.
And then the alternative null hypothesis is P is greater than 0.4.
Let me see. A new technique will improve the number of plants. That'll be more than 4 out of 10. Yeah. So P is greater than 0.4.
Okay. And then would you have the upper as 20 and you guess the lower?
Yep.
Okay. And it has to be below 0.05.
Yep.
I got 13. So P is greater than or equal to, right?
Well, so the critical region is X. Well, what was the probability of that one?
Like the lower number is 13, which is equal to 0.02102 or 3.
So let's say probability X is greater than or equal to 13. That's 2.10%.
Yeah.
And so the critical region is X is greater than or equal to 13. X is greater than or equal to 13.
Yeah.
Yeah. So 13 or more. Yeah. Okay. B.
So the critical region is like it's true because more than 0.420 plants have germinated, which is
so big picture is, did her new technique work or not? That's what
yes,
that's what H1 are about. So did the new technique work?
yeah,
Yep, that's it. New technique worked. That's H1. You can just write down, the new her new fertilizer was successful.
yep.
Yeah, and what was this? 0.4 times 20 seeds is 8 seeds. Yeah, and so if it was like 9, the fertilizer worked. Probably not. 9, it's just random chance.
Yeah.
Whereas
But we 14, which is all the way on the right.
yeah, and so this one was actually 14, which is has a less than 2% chance of happening, and so by random chance. Yeah.
Yeah.
Okay, we're getting somewhere. So this stuff, there's a million of these. All right, two-tailed tests. Let's do it. For a two-tailed test, let me just. They start with. Yeah, they're not messing around, Eddie. I'm gonna go with this one. Go with this. Let me just put a thing, a number 1 on that. Okay. All right. Yeah, I think this looks good. Notice a difference. So this is some binomial distribution thing, right?
Yeah.
Probability 0.25 is the null hypothesis. Alternative hypothesis is the probability is not equal to 0.25.
Yep.
What's that about? Up until now we were saying like either it's the biased towards heads or it's biased against heads. In this case, we're just checking, is it biased in general?
Yeah.
And so the way you do that is a 10% level of significance. You do 5% either end.
You half the significance.
That's it. Okay. Using temp, so find the critical region for this one. So it's going to be 2 critical regions.
Okay. So the Numitral would be 30.
Yep.
And P is 0.25.
Yeah.
So for this, would you do would you do the upper as 30 and you'd find out the lower by guessing the number?
Yep.
Below 5%.
Mm-hmm.
I got 13.
Okay. So x is greater than or equal to 13.
Which is 0.021592.
Say it again, sorry.
0.021592. No, 3. No, wait. 0.21594. Yeah.
Okay. And actually, let me just write it the way they write it. X is between 13 and 30. Yeah. Okay. What's next?
And then you work out the upper now.
That's the upper.
The lower. So
I think I know what you mean. Yeah, I think I know what you mean.
So would you change the upper but keep the lower as 0?
Say it again.
Would you keep the lower as 0 and change the upper?
Yep.
So I got 3 as the answer.
So the lower critical region would be x is between 0 and 3. And what's the probability for that one?
That is 0.0374445.
5. All right, question B.
Okay. So for this part, would you add the probabilities together, the answers?
Correct.
Okay. Which is 0.059039.
0.05039.
Yeah.
And so that is 5.04%. Question C.
So would we draw what we drew on the left?
So on the left, you've got 0, you've got 3, you've got 13 and 30.
30. But it says you need to draw something for the answer. Can be drawn.
No. Can be concluded or something.
Oh, right, okay. So we could say that what do we need to conclude? Is it that
like the whole like H1 like is it
okay.
Did it work, did it not type of stuff?
So is it H1 because it's not equal to 0.25?
No. So 11 is like here.
Yeah.
And what is this? This is 0.25 out of 30. So that's like 7.5 is in the middle.
Yeah.
11 is a bit higher than 7.5, but not very much. So that's just probably random chance. It would have to be 13 or more. So that's inside the acceptance region.
Yeah.
Outside the critical region, and so that's H null. So in here is H null, here is H1, here is H1. Yeah.
Oh, because our answer is just above the significance level, meaning that it's still accepted.
It's basically like it's a bit above the average, but not very much. So it's probably just random chance.
Yeah.
This time it was a bit extra. Next time it might be a bit less. It would have to be like 13 or more. Given that the average is 7.5, 13 or more is like less than 5% chance. Yes. So that one is H null. Like it's inside the acceptance region. Yeah, inside the acceptance region. Right, let me now go back. Right, let's give this a go.
Okay. So for this, would you have x is binomially distributed?
Yeah.
And then it'd be 10 and then 0.05. Is that right?
No. 2 to 1. It's a bit weird.
Yeah, that's what I was thinking.
So what's that as a fraction?
2 over 1.
No. I'm teaching this to a girl in year 7. How many parts in total?
3.
Yeah, that one's 2/3. That one's 1/3.
Okay.
So non-vegetarian to vegetarian is 2 to 1. Whether or not proportion of eating vegetarian. So we want vegetarian. Ratio of non-vegetarian to vegetarian. So that's non. That's veg. So we want vegetarian. Okay, what's next?
And then we get H null,
Mm-hmm.
which is B equals 10. Oh, no, a 1/3.
Yeah.
And then the alternative is P is greater than.
This one, he wanted to check if it's different. So it could be greater than, less than.
B, okay.
Less than would also be different. And so you deal with it like that. It's not the same. Okay, how do we do this?
Okay. So we have the Numa trial is 10, probability is 1/3, which is 0.333. Yeah.
You can do 1 divided by 3 and it will do it.
Okay.
It puts it in for you.
Okay.
Okay, 1 person out of 10 ordered a vegetarian meal. So what do we do?
So would you have the upper as 10 and the lower you just put a number in?
Well, 1 person ordered a vegetarian meal.
So it would be 1 as the lower then.
Okay, so try that. That'd be
And
the upper tail.
what would be the upper? Would it be 10?
Yeah.
0.98266.
So that's like a 98% chance of 1 or more people ordering a vegetarian meal
Yeah.
out of 10. And so that's not very rare.
Yeah.
What would you conclude?
Conclude that would it be the null hypothesis?
Yes. However, this is two-tailed test.
Oh, so it's both sides.
So you have to check lower side as well.
Okay. So for this, would you put the lower as 0 and the upper as 1?
Correct.
I got 0.104049.
All right. So that's 10.4%.
Yeah.
Okay. And so have the proportion of people eating vegetarian meals, is it now different at the 5% level? Nope. That's greater than 5%. And so
Oh, okay.
the critical value is like in here. That's going to be somewhere in there. This one here is like 10% of the stuff is in there.
Yep.
Yep. And so that one is H null. Hasn't really changed. Let's just make sure. And there's also a trick to this one, which is it's actually 2.5% that you have to look for, even though it said 5% level of significance, because it's two-tailed.
Yeah.
So it's insufficient, yeah. And so it's H null. Anyway, we did our best. What do you give yourself for that stuff?
Probably a half.
That's hypothesis testing anyway. There's no more stuff. I think
Yeah.
just practice it. I'm going to change this lesson. I'm going to change the way I put. I'm just using the questions, but I'm going to break them down more. I think because no one really understands it. Yeah, how was that for you, Adam?
That was good.
And so I think you're finished stats, and so we're on to mechanics now.
Yeah.
How does that sound?
That sounds good.
Any questions for me in general?
No.
All right. Well, well done, Adam. You did great.
Thank you.
And have a nice weekend.
You too. Bye.
Cheers. Goodbye.